Boys and girls, this is lesson 3.5, and it's called solving two-step equations. So far, we've only solved one-step equations. So today's kind of like the next step of that. So let's first start off by solving some one-step equations to kind of recall some of the information that we already know. And then we'll move into solving these two-step equations. And it'll become very obvious what I mean when we say one-step equations or two-step equations. After this lesson, you're going to be like, okay, I think I see. I think I get that. Okay, so first let's begin by recalling here. So let's say recall. When we're solving equations, the whole goal is to isolate x. We want x to be all alone. So sometimes we want like x equals, right? See how x is all alone? And our answer will be something like that. I don't know what our answer will be. I don't know. Let's just say it's like -3 or something like that. See, x is all alone. It's isolated. There's nothing else with it. It's just x. It's a singular positive variable. It's really one x, but we just write x. So our whole goal of equation solving is to isolate x. Now, in order to do that, so it says here, in order to isolate x, we use opposite operations to undo the operations that are on the same side of the equal sign as x. So that's exactly it. It's like the opposite operation would be like, okay, what's the opposite of -3? It would be +3. What's the opposite of +9? It would be -9, and so on and so forth, kind of like that. That's pretty much what we're used to so far. So we basically just continue this process until we have an x all alone. And once x is alone, it's a singular positive x like this that we have here. And the other side is a number. We're pretty good. We've pretty much solved the equation. So let's do some examples of some one-step equations. Let's have a look here. We have here something +4, or x plus 4 equals -7. Now, I know that you know a clever way to do this. Yes, we know. We could probably already know what the answer is, and that's great. That's good. However, it's important that we nail down some sort of technique, some sort of process here, so that when we're moving into two-step and beyond types of equation solving, then we're going to have at least some sort of method that we can apply to any equation to solve for any variable. Sorry about my voice. So first and foremost here, we have x plus 4 equals -7. So we want to undo the +4. We want to do the opposite of +4 because the +4 is on the same side as the x. So how can we get rid of this +4? Well, you guessed it, we're going to -4. If we -4 from the left side, now when I say left side, like if this is the equal sign, over here's the left side and this is the right side, LSRS. So what we want to do is take away 4 on both sides of the equation. So that'll look something like this. Notice how I put the -4 in different colors. I think that's really helpful for some of us. So we have x plus 4 minus 4. This ends up being 0, right? +4 minus 4, it ends up being goodbye. And on the right side, we just have -7 minus 4. And then our last, we'll just simplify each side here. So on the left side, we just have x. And on the right side, it looks like we have -11, -11. And that's our answer, x equals -11. Wonderful, isn't it? Let's look at the next one here. We have 3x equals -18. Now, it's important to note here that there's no plus sign, there's no minus sign, right? So we just have a 3x. Many of you can already tell that what's going on between the 3 and the x is multiplication. Like 3 times x equals -18. So maybe you're thinking 3 times something is -18. And you could probably sit there and think of this something. But again, it's important to nail down a process so that we know what to do for the tougher ones, for the much tougher ones that come along in this course. In order to get rid of the multiplying 3, we're going to have to divide by 3. So we're going to divide each side of the equation by 3. So that means we're dividing the left side and the right side both by 3. And what happens is this multiplying 3 cancels with this dividing 3. So all we're left with on the left side is x, and negative 18 divided by 3. Where's my calculator? Where's my calculator? Oh, here it is. Negative 18 divided by 3. Plug it in. You got negative 6, negative 6. Okay, good. Negative 6. Lovely. And that's it. That's the end. Then what we did in Unit 2 was we kind of got a little spicy with these things. Notice over here, this is our equation, right? So if I split it, like this is the left side, and this is the right side, right? Just so we know. So on the left side, we have negative 6x plus 2x. And on the right side, we have 14 plus 26. Now, if you're ever able to, and in this case we are able to, if you're able to collect like terms, go ahead and do that immediately. On the left side, negative 6x plus 2x, well, they combine and create negative 4x. And on the right side, 14 plus 26, well, that's just 40. So we end up with negative 4x equals 40. All we've done here is no opposite operations. We've just kind of simplified each side of the equation. Now from here, we have negative 4 times x equals 40. Now, how do we get rid of a multiplying negative 4? We are going to divide by negative 4. So we divide each side of the equation by the coefficient of x. The negative 4 is the coefficient. So we divide each side by negative 4. Right? The negative cancels with negative. The 4 cancels with 4. We're left with x equals negative 10. And that's the end. And that's that. Now, before we move on, let's solidify a couple things. Firstly, these are called one-step these are called one-step equations because we are simply doing one opposite operation to isolate x. Like in example A, one opposite operation we did was take away 4 from both sides. Example B, the one opposite operation that we did was divide each side by 3. In example C, the one opposite operation we did was divide by negative 4. Now I know we did have to collect the like terms to get to this step, right? But in terms of solving equations, in terms of opposite operations, we just did one of them. And that's why these are called one-step equations. You might have worked with these in grade 7 and 8. Now, one other thing that's important to kind of remember is something that we talked about in the previous unit. Sorry about that. X, this example, equals negative 11, right? And it's clear. You're like, yeah, I know. Maybe you were thinking this. You were like, well, x something, right? Something plus 4 equals negative 7. Maybe you're thinking that. You sat there and you're thinking of numbers to put in here, right? But the algebra tells us that x is going to be negative 11. So the magic number that fits in there is negative 11, right? Watch what happens. Negative 11 plus 4, well, that is negative 7. And then on the right side, we also have negative 7. So now it just looks kind of weird. Now we have negative 7 on one side and negative 7 on the other side. However, when the left side of the equation is equal to the right side of the equation, that is a true statement. It's a true statement. And when math screams true statement at you, like negative 7 equals negative 7, math telling you that you've done something correct. The answer is correct. And a lot of math people will say, okay, well, that just means left side equals right side. Yes, right. You might have heard that before in your math life. But truly what's happening here is that the math brings about a true statement saying negative 7 equals negative 7. And because that's true, negative 7 is literally equal to negative 7, we say left side of the equation equals right side of the equation, and we know that we've gotten this answer correct because, well, the math kind of just told us that. And that will happen for any of these equations if we were to check them. So maybe we can check this one. 3, that's not a 3 equals, well, the math times -6, -18. Well, right side, we just have -18. Right? Yeah. Left, the right side is a big check. Like, for example, what if you got like -9 equals -18? That's false. That's not true. Therefore, something in your math might be incorrect because your answer might have been incorrect. Okay. That's enough of one-step equations. Let's move into something called two-step equations. So, as your first, consider the following equations. All right, no problem. It says, notice that we must undo more than one operation. Like, have a look at this first one. We have 5 times x, take away 10, equals 50. Now, at some point, you're probably thinking we gotta add 10 to each side because we have a -10. At another point, we're gonna have to divide everything by 5 because we have a multiplying 5. What is the order that we do that in? Are we gonna divide first, or are we going to add 10 first? What is the order? Now, I like to think of BEDMAS. I think of BEDMAS backwards for equation solving. We call it SAMDEB. Notice how it's just BEDMAS backwards, like BEDMAS, but we call it SAMDEB, the opposite of BEDMAS. We're going to use this to solve equations. So when we're looking at this first one here, this first example, let's think of SAMDEB. The first thing we're going to have to do to solve this equation is to first attack the addition or subtraction. In this case, we have a -10. So in order to get rid of the -10, we're going to have to add 10. And whatever we do to one side, we have to do the same thing to the other side. So we're going to have to add 10 to both sides of the equation. So it'll look something like this. 5x minus 10 plus 10 equals 50 plus 10. And this will always happen. We always end up with a 0 going on here, right? -10 plus 10 or -10 plus 10 ends up being nothing. So on the left-hand side, we're just left with 5x. And on the right-hand side, we're left with, well, 50 plus 10, I guess, is 60. This is what we're left with. Now, at this point, it looks kind of familiar, doesn't it? We have a multiplying 5. How do we get rid of this multiplying 5? Well, we're going to divide by 5. And whatever we do to one side, we got to do the same thing to the other side. Divide each side by 5. And when we do that, we get x equals 12. Because these 5's cancel. And off we go. See that? Notice in this particular problem, we had to undo 2 things. First, we had to undo the -10, and then we had to undo the multiplying 5. And that is what two-step equations is all about. It's about doing 2 opposite operations. Things to note here before we move on. First of all, notice that I am writing plus 10 on each side here. I do that on purpose. So please fall into that habit. It might seem a little bit ridiculous. I know. Maybe you have a better way, but I promise you, this is the best way to be doing it. It is the best. And I say that not because I'm the teacher and we should be following the teacher, whatever the teacher says. No. It's because, folks, I know where we're going in this course. I know where high school math goes in grade 10, 11, and 12. And I'm telling you, if you follow this routine, you're going to be in phenomenal shape for any grade level of equation solving. Another thing to note here is that when we show dividing 5, we do not do the divide 5. We do not do that. No. We don't want to do that. We want to show it kind of like a fraction notation. So kind of like a divide 5, kind of looking like a fraction type of thing. Okay, how about this next one? We have 3x plus 6x plus 15 equals negative 3. Looks a little weird. It might be a little weird because if you look closely, we have two of these x terms, right? We have a 3x and a 6x. So the first thing we're going to do, whenever possible, if you're able to collect like terms that are on the same side of the equation, then do it. Absolutely do it. So 3x plus 6x is going to be 9x. So we're going to write out this whole thing. 9x plus 15 equals negative 3. Oh, it kind of looks a lot like this first one, doesn't it? It looks a lot like this one. So now, according to Sam, Deb, we're going to have to start undoing stuff. When we start undoing stuff, we're going to have to first look at the addition or subtraction. And notice here, we have a plus 15. So in order to get rid of a plus 15, we're going to subtract 15 from both sides of the equation. So we took away 15 from the left side. We also took away 15 from the right side. So again, this will always end up kind of being 0 here, right? Plus 15 minus 15 is 0. It's gone. So on the left side, we're just left with 9x. And on the right side, we're left with, okay, I'm going to pull out a calculator here because I always mess these ones up. Negative 3, take away 15 is negative 18. Okay, negative 18. There you go. Now, we're getting closer. Sam Deb says now look at the multiplication or division. And if we look here, we see I'm multiplying 9. So in order to get rid of this multiplying 9 here, we're going to have to divide by 9. Whatever we do to one side, we're going to have to do the same thing to the other. So divide each side by 9. This 9 cancels with that 9. We're left with, well, the computer's frozen. That's what we're left with, a frozen computer. Oh dear. Okay, my computer froze, but we're back, I think. I hope. Divide each side by 9. These 9s cancel out like that. And we're just left with x equals, and then whatever the result of negative 18 divided by 9 is, I think it's negative 2. Okay. Phenomenal. Now, it wants us in this problem to check our answer. We're going to check them. I like to put a little title called check because we're going to check these things. So let's first start by checking example 1A. So the first thing I'm going to do, I'm going to write the equation down. 5x minus 10 equals 50. Now, our answer was x equals 12. So what we're going to do here is we're going to check that answer. We're going to check, maybe you want to say if x does equal 12. We're going to check if x equals 12. So what we're going to do is we're going to replace this x with 12. So instead of 5x, we're going to write 5 times 12, take away 10 equals 50. Now, we are checking. That means is we're going to almost like trying to draw a line here. We're checking the left side and the right side. So I like to draw a line kind of like that. It goes all the way down through the equal sign because it separates the equation to the left side and the right side. 5 times 12 is 60. Take away 10. 60 take away 10. Does that equal 50? Yeah, it does actually. So there you go. Look at that. 50 equals 50. Perfect. That is a true statement. It's true. We're happy about that. What we can say here is the left side equals the right side. We can give ourselves a check mark and say, you know what? We got the answer right. Because when we took our answer and put it into the equation, the left side and the right side came out to be a true statement. 50 does equal 50. Okay. Over here, for example B, we're going to first start off by writing this whole equation down. Maybe at this point you can say, all right, well, we're going to split the equation to the left side and the right side by drawing a line like that. So like over here is the left side, over here is the right side. Okay? Now we're going to check to see if x equals -2. We're going to check x equals -2. But notice how there's two spots for x? Look at this. There's a spot there and a spot there. No problem. We're going to put in -2 each time you see an x. So 3 times -2 plus 6 times -2 plus 15. And on the right side, we got -3. So let's go ahead and a bit. We got -6 plus -12 plus 15. I go right to my calculator here. I don't want to be doing a ton of mental math at all. So I go to my calculator, -6 plus -12 plus 15. And you press equals. And you know what that is? It does equal -3. It does. So -3 equals -3. That is a true statement. Say, okay, left side does equal the right side. Solves a check mark, and we can move on with our day. Yeah? Not too shabby at all. Okay, now I do want to show you how this linear relations these linear relations we've been working with, how they can kind of play a role in two-step equations. So check this out. Oh, sorry, I'm getting ahead of myself. I'm really getting ahead of myself. Find the root of each equation. Find the root. The root? Okay, well, that's just a fancy way of saying, well, find x, find the value of x. And the reason why I wrote it like that is not because I'm trying to trick you at all, but it's because sometimes our textbook will ask the question like that. And more importantly, sometimes EQAO will ask a question like that. It won't say solve for x or find the value of x. It'll say find the root of each equation. And when we say find the root of each equation, we're really just looking for x. That's all that means. In this first one here, example 2a, notice we got 4x plus x plus 2 minus 5 equals -22. So first and foremost, I noticed that we can collect these x terms like that, 4x plus 1x. We can also collect +2 take away 5. So let's go ahead and just clean that up. Something like 5x, right? 4x plus 1x is 5x. +2 take away 5 is -3. Yeah. And now at this point, it looks very familiar to the previous example, doesn't it? We're going to have to get rid of this -3, first of all, because SAMDEB, I'm going to write SAMDEB up here. SAMDEB says to focus on the subtraction and addition first. So we're going to have to get rid of this subtract 3. And the way we do that is we add 3, and we're going to add 3 to both sides of the equation. So -3 plus 3 ends up being nothing, right? That's 0. So the left side, we just have 5x. The right side, we have 25. Is that right? 25? Yeah. And now from here, we are going to divide each side by the coefficient, which is 5. Right? That 5 cancels with that 5. And then we just have x equals 5. Okay. Lovely. That's that. Great. Now, if you really want, we could, for example, we could check this. We could check this. So maybe I'll put a little title here. It says, let's check x equals 5. And what we're going to do is take our original equation at the very beginning here, this one, and we're going to sub in 5 for x. So we have something like 4 times 5 plus 5 plus 2, take away 5. Well, first, 4 times 5, I guess, is 20. So we have 20 plus 5 plus 2 minus 5. Does that equal -22? And sure enough, it does. It does. So we say here, yes, the left side equals the right side. We can give ourselves a big check mark and say, yeah, we're good at this. We are really good. I'll give you a moment to write that down. Let's move on to example B. No, this one looks a little weird. Okay, the reason why I say it looks a little weird is because we got the x's on the right hand side, which doesn't really mean anything. It doesn't really change anything, but it does look a little different than what we're used to. Now, first and foremost, we have 9 take away 20. And what we're able to do is we can collect those like terms. On the left side, we have 3x and minus 4x. Go ahead and collect those like terms. After simplifying each side of the equation, we end up with something like negative 11 equals negative 1x minus 8. Yeah. Now, at this point, we look at on the side that has the x. What we want to do first, according to SamDeb, is get rid of the subtraction or addition. We're going to get rid of the minus 8. How do we get rid of minus 8? We're going to add 8 side. So we're going to add 8 to the right side, and we're going to add 8 to the left side. Now, minus 8 plus 8, they cancel each other out like that. That's 0. It ends up being nothing. On the left side, we get something like negative 3 equals negative 1x. It looks like it's almost done, doesn't it? But remember, we don't want negative x, rather, or negative 1x. We want positive x. So we're going to have to get rid of that negative 1, that multiplying negative 1, by dividing each side here by negative 1. Negative 3 divided by negative 1 is just positive 3. So you could have 3 equals x, or you might say x equals 3. It's the same thing. 3 equals x is the same thing as x equals 3. But some people might like to see it like that, and that's okay too. Okay, let's go ahead and check this one just to see. We're gonna check x equals 3 for this one here. We first start off by writing the original equation, the very first one, is this top one there. And what we're gonna do, we're gonna have to first, we're gonna now sub in x equals 3. So when I draw my line like that, we're gonna sub in x equals 3. So on the right side, it'll look like, right, instead of 3x, it'll be 3 times 3. Take away 8 minus 4. Instead of 4x, it's going to be 4 times 3. Let's start doing some math. Let's start simplifying each side here. 9 take away 20 is negative 11, okay? And on the right side, we have, well, 3 times 3 is 9. Take away 8 minus 12, okay? We put that whole right side into our calculator. I'm going to go 9 minus 8 minus 12. And the calculator says negative 11. And look at that. The left side equals the right side. And we can give ourselves a great big check mark and say, yep, we got the right answer here. X must equal 3 because the math kind of checks out there. Okay. Now is where I'm going to show you how this linear relations stuff really blends itself nicely into two-step equations. Have a look at this word problem. Steve has $2,600 in his bank account, and he spends, that's a key word, right? He spends $40 per week. Steve has $2,600 in his bank account to begin. He spends $40 per week. This kind of might sound familiar. Now they say the variable A is going to be the amount in his account, and the variable W is going to be the number of weeks. So first they want us to come up with some sort of equation to model the amount of money in Steve's account. So the amount of money in Steve's account, right? The amount of money is $2,600, right? He starts with $2,600. He's spending, so he's minusing $40 for every week, right? So that would be our equation. The amount in Steve's account is $2,600. Spending $40 for every week. How much money will he have in his account after 1 year? 1 year. Hold on. 1 year. 1 year. Well, this W represents per week, right? This equation is not built for years. It's built for weeks. So we got to think to ourselves, well, if he's spending $40 every week, right? Then how many weeks is that? How many weeks? How many weeks are in a year? Well, I think there'd be 52 weeks. So this is telling us the number of weeks is going to be 52. Because there's 52 weeks in a year. So we're going to first start off with our equation, right? 2600 minus 40W. We're going to replace this W with what W equals, 52. 2600 minus 40, or 2600 minus 40 times 52. Now I go to my calculator, I'm like, okay, well, what is 40 times 52? Is going to equal 2600 minus 2080. Let me double check that. 40 times 52, 2080. And now, well 2600 take away 2080 is just 520. That's it. So A equals 520. Remember, A is the amount in Steve's account. When 52 weeks go by, the amount is $520. So we can say, well, therefore, Steve will have $520 in his account after 1 year. Remember, 1 year was just 50 weeks. That's all they're saying there. They're just trying to trick us a little bit. Now, that example might be very intuitive. You might be like, yeah, I could do that. And you might fall into a bad habit of not using the equation. Like when I say using this equation, please, folks, please use this equation. Always use the equation that you're given. I know you could probably just kind of do it intuitively, but even when you're doing this math intuitively, you're doing the same thing. You're still doing 40 times 52, and you're taking 2600 and minusing that result. So it's important that we show the math like this using our equation, because this is what we call proper math form. Math form is it's very important to have and develop good mathematical form, folks. And it's because, well, in grade 9, it might seem irrelevant. You're like, Mr. Yakovich, why do we have to do this? Why do we have to do that? And that's because I'm trying to prepare you for the tougher stuff that you're going to see in grade 10 and 11 and 12. Okay. Last one. We have how many weeks will it take Steve to have a balance of $1,200? So the amount in his account, how many weeks is it going to be for the amount to be $1,200? That's what they're saying here. They're basically at how many weeks. What is W? What is W when A is 1,200? Well, we're going to go back to our equation. We're going to first start off with our, where did I write it? I write it here. It's a weird spot. It is a weird spot. Yeah, see how this is right here. Okay, we start off with our equation. A equals 2600 minus 40W. We want to know what W is when A is 1200. So we're going to replace A with 1200. 1200 equals 2600 minus 40W. This is where two-step equations really lends itself really nicely here. We're going to have to solve for W. We want to isolate and solve for W. So in order to do that, we're going to have to get rid of this 2600. So how do we get rid of this? I mean, it doesn't say negative 2600. We know it's a positive 2600. So to get rid of the positive 2600, we're going to have to subtract 2600 from both sides. So we take away 2600 from the right, we take it away from the left, and 2600 minus 2600 just 0. So that's nothing. So on the left side, we end up with negative 1400. And on the right side, remember, it was minus 40W, so we end up with negative 40W. Now, in order to get rid of this multiplying negative 40, we're going to divide by negative 40. And whatever we do to one side, we have to do to the other. And the negative 40 cancels with the negative 40. We end up with, let me kind of move this. I'm running out of room. I'm going to move it over here somewhere. 35 equals W. So it's going to take Steve 35 weeks to have a balance of $1,200 in his account. So we'll say, therefore, it will take 35 weeks with a period at the end. Okay. So, folks, that is two-step equation solving in a nutshell. There is some homework associated with this, and please get started on it. Put your name, the date, and a title on a separate piece of paper, and let's begin solving these two-step equations. If you might have any questions, please feel free to either visit me in the math help room, or perhaps send me an email, send me a message on Remind. I'm always here to help. Okay. Take care.